Hey guys, tonight we drift far beyond the cities, beyond the last porch light, beyond the pale wash of the moon, into a part of the universe where space is not empty in the way people often imagine, but softly filled with color, dust, and quiet light. You can picture it almost immediately. Enormous clouds hanging in the dark, glowing faintly in red, blue, violet, and gold, as if the night itself has learned how to breathe. Before you get cozy, take a moment to like the video and subscribe, but only if you genuinely enjoy spending time here with me. And if you feel like it, leave a comment telling me your location and local time, because there is something deeply nice about knowing where in the world this sleepy little journey is finding you tonight. Let the world slow down for a moment, let the fan murmur softly nearby, and let's slip into tonight's journey together. A nebula is very simply a cloud in space. That sounds almost too plain for something so beautiful. It feels like calling the ocean a puddle with ambition. But the basic idea really is that gentle. A nebula is a vast region of gas and dust floating between the stars. Some are bright enough to glow. Some are dark enough to hide the light behind them. Some are places where stars are just beginning. Some are the soft remains of stars that have already lived out their long lives. And somehow, even with all of that science wrapped around them, nebulae still feel strangely personal when you look at them, as if the universe decided to paint in slow motion. You can think of them as weather for the galaxy, though far calmer and much less likely to ruin your weekend plans. Here on Earth, clouds gather because air and water move through an atmosphere. In space, there is no open blue sky and no breeze moving through trees, but there is still matter drifting through the galaxy. Hydrogen, mostly. A little helium, tiny grains of dust made from heavier elements. All of it spread so thinly that if you were somehow inside a nebula, you would probably not notice much at first. You would not feel fluffy mist on your skin. You would not wave your hand and watch cosmic fog swirl around your fingers like a stage effect in an over-enthusiastic theater production. Nebulae look rich and dense from far away because they stretch across astonishing distances. Their beauty comes from scale, patience, and light. That is one of the most soothing facts about them. A nebula can be wider than many solar systems put together, sometimes dozens or even hundreds of light years across, and yet the gas inside it may be much thinner than the best vacuum humans can create on Earth. So when you see one in a photograph, broad and luminous and almost velvety, what you are really seeing is something incredibly delicate spread across an almost ridiculous amount of space. The universe does this a lot, actually. It takes very small things and arranges them over very large distances until they become majestic, which is rude, honestly, because it makes everything sound simple right before it becomes overwhelming in the most elegant way. The word nebula has a long history. It comes from a Latin word for mist or cloud, and that old meaning still fits beautifully. Long before modern telescopes gave us sharp images, observers looked into the night sky and noticed faint fuzzy patches that did not appear as crisp points like stars. They were little smudges of light, soft-edged and mysterious. Some of those turned out not to be nebulae at all, but distant galaxies so far away that they blurred into pale shapes. Others really were clouds inside our own galaxy. For a long time, the sky kept those categories to itself. It did not seem in any rush to explain the difference. That slowness is part of the charm. Nebulae teach you very early that the universe is under no pressure to be quickly understood. It glows softly, keeps its distance, and waits for patient eyes. When astronomers began studying nebulae more carefully, they found that these clouds were not all doing the same thing. Some shine because nearby stars flood them with energy. Some reflect starlight like faint cosmic smoke. Some remain dark and visible only because they block brighter regions behind them. So even at the beginning of the story, Nebulae are already doing something calming and slightly magical. They are showing you that darkness and light are not always opposites. Sometimes one reveals the other. Sometimes a shadow only becomes beautiful because a glow sits behind it. Keep that image nearby, because it matters more and more as the night goes on. And the colors matter too, though we will come back to them more fully later. For now, it is enough to know that a nebula's glow is not random decoration. Those colors can tell you what kind of gas is present and what has energized it. Hydrogen often gives off a reddish light when excited by nearby stars. Oxygen can shine in greenish or blue-green tones. Dust can scatter light in a cooler blue. So when you look at a nebula, you are not just seeing something pretty. You are seeing physics behave with unusual grace. Chemistry, light, and distance all cooperating to make the dark feel inhabited. That may be one reason images of nebulae feel so emotionally different from images of planets or stars. A planet looks solid. A star looks bright and self-contained. A nebula looks open. It looks like a thought still forming. It feels unfinished in the best possible way, as if the universe left part of the canvas loose and drifting on purpose. You can imagine floating near one very slowly with no need to arrive anywhere. No rushing, no mission briefing, no dramatic countdown, just a huge region of space where atoms, light, and gravity have entered into a long, quiet conversation. Some parts would glow, some parts would darken, some would appear as soft folds and curtains, and all of it would be happening without sound because space carries none in the way air does. That silence changes the feeling completely. A thundercloud on Earth suggests noise, rain, movement. A nebula suggests stillness, even when important things are happening inside it. And important things do happen there. Nebulae are not only beautiful decorations hanging in the galaxy for your late-night appreciation, though they are very good at that. They are part of a larger cycle. The material inside them can become stars. The remains of old stars can create new nebulae. Elements formed in stellar interiors can be scattered into space and mixed into future clouds, future systems, future planets. Even the atoms in your body, carbon and oxygen and more, belong to that wider story. Not in a dramatic, poster-on-the-classroom wall kind of way. In a real way, a calm way. The universe is very old and it recycles with extraordinary patience. So when you look at a nebula, you are seeing more than a cloud. You are seeing a place where matter is between roles. It is not settled. It is not finished. It is waiting, glowing, drifting, hiding, revealing. And for something so vast, it asks for very little from you except attention. That is why nebulae feel so easy to love at night. They do not glare, they do not demand. They simply remain there in the dark, suspended between mystery and explanation. A star can feel sharp. A galaxy can feel enormous. A nebula feels intimate in a strange and impossible way, even when it spans distances that the mind cannot comfortably hold. It meets you halfway. It says, here is something ancient but soft-edged. Here is something scientific but still dreamlike. Here is something real, and yet it looks almost as if it belongs in imagination. Soon, that soft cloud will begin to separate into different kinds of light and shadow, and the colors will start telling a more detailed story. You will see that some nebulae glow because they are energized from within their neighborhoods, while others shine by borrowed light, quietly reflecting what falls upon them. And that little distinction, so gentle at first glance, changes the whole mood of what you are seeing. That borrowed light has a quiet charm to it, because a nebula does not always make its own visible glow. Sometimes it shines because a nearby star is doing the heavy lifting, pouring light into the cloud, and the cloud simply answers by scattering part of it back into space. It is a very graceful arrangement. One object burns with intensity, another softens the result, and from far away you receive something that looks almost tender. In astronomy, that kind of cloud is called a reflection nebula, and its color is often blue, for a reason that feels strangely familiar once you hear it. Blue light is scattered more easily than red light when it passes through fine particles. Earth's sky looks blue for basically the same reason, though the details are not identical. So when you see a blue reflection nebula, you are seeing starlight sifted through dust in a way that favors shorter wavelengths. It gives the cloud that cool, dreamy tone people often associate with moonlight, silk, or expensive ambient lighting in a hotel lobby that wants you to feel peaceful and slightly more elegant than usual. The universe, with no concern at all for interior design, has been doing this for ages. Other nebulae glow for a different reason. Their gas is energized by intense ultraviolet light from hot young stars nearby. That light strips electrons from atoms in the cloud. Later, when those electrons settle back into lower energy states, they release light at specific colors. This is why some nebulae shine in rich red, pink, or greenish tones. These are called emission nebulae because the cloud itself emits visible light. The color is not decorative, it is a signature. It is the gas quietly telling you what it is made of and what has happened to it. Hydrogen, the most abundant element in the universe, often plays the leading role. When hydrogen atoms in a nebula are excited and then relax, one of the strongest visible signals they produce is a deep red light. This is why so many famous nebula images seem brushed with crimson or rose. That reddish glow is often the mark of ionized hydrogen, sometimes written as HII, which simply means the hydrogen has lost its electron for a while. It sounds technical, but the picture is gentle. A star shines fiercely nearby, the gas responds, and the cloud glows red in the dark like a slow answer. Oxygen can join in too, especially in some hotter or more energized regions. Ionized oxygen often contributes green or blue-green light. Sulfur can add deeper red tones, so a nebula is not only a cloud, it is also a kind of color conversation between atoms and radiation. The image you see is part chemistry, part physics, part distance, and part patience. If you could somehow watch over thousands of years with your own eyes, the cloud would still seem almost still. Yet inside that stillness, atoms are constantly absorbing and releasing energy, quietly painting the dark. This is one of the loveliest things about nebulae. Their beauty is not separate from their science. The beauty is the science, made visible. That helps explain why nebula photographs can look almost unreal at first glance. The colors seem too rich, too theatrical, too carefully arranged, as if some cosmic artist had a weakness for dramatic gradients. But the light is real. The structures are real. The atoms are real. What sometimes changes is the way the image is processed so human eyes can better see faint details and different wavelengths. Nebulae are usually much dimmer in the sky than photographs suggest. Your eye, even under excellent dark conditions, does not gather light for long exposures the way a camera can. So the camera becomes a patient collector of faint glow, and then the image reveals what was always there but too subtle for quick human sight. There is something calming in that too. The universe is full of beauty that does not rush to be noticed. Some nebulae are also colored by dust rather than glowing gas. Dust grains can reflect or scatter light, making the cloud appear blue, while thicker dust can dim and redden the light passing through it. This is why some regions look cool and luminous while nearby lanes appear smoky, brownish, or almost black. The scene can feel layered, as if the galaxy were working in watercolor and charcoal at the same time. You may have one bright region where young stars energize hydrogen into a pink-red glow, another where blue starlight is reflected off dust, and nearby shadows where thicker dust blocks the background. All of it can exist in the same neighborhood, giving a nebula its depth and mood. And mood matters more than you might expect in astronomy, because the way something looks often points directly to what it is doing. A red emission nebula usually tells you there are hot stars close by, bright enough to energize hydrogen. A blue reflection nebula often suggests dust reflecting the light of stars that may not be hot enough or close enough to ionize the gas in the same dramatic way. Dark regions hint at denser dust clouds, so even before you know the technical labels, your eye is already gathering clues. You are reading a cosmic landscape almost the way you read weather in the distance, except the distances are absurd, and the timescales have absolutely no respect for your planner. Sometimes the colors in astronomical images are adjusted to show details that would otherwise remain hidden. Telescopes can observe light beyond the narrow range visible to human eyes, including infrared and ultraviolet. Scientists may map those wavelengths into visible colors so structures become easier to study. That means some nebula images are partly interpretive, though not in a dishonest way. It is more like translation than invention. The goal is to reveal the story carried by the light. And light has a great deal to say if you let it arrive on its own schedule. Remember that, because the slowness of light will matter soon. For now, stay with the colors themselves. Picture a cloud where red glow pools around newborn hot stars, while nearby blue dust reflects softer light like a cosmic veil. Picture edges where radiation carves shapes into gas, leaving bright rims and gentle shadows. Picture a place so thin and cold and distant that it should feel abstract, yet somehow it looks almost touchable in photographs. That strange closeness is part of the spell. Nebulae invite your imagination without breaking the facts. They also remind you that color in the universe is often a message about energy. Hotter stars tend to emit more intense ultraviolet light, and that light can alter the surrounding gas. Dust can survive in some places, be destroyed in others, or gather into denser folds that block what lies behind. So the colors are not painted onto the nebula like makeup. They emerge from ongoing relationships between starlight, atoms, electrons, and tiny solid grains. Space may look silent, but it is not inactive. It is full of exchanges so delicate that they seem almost polite. And still, for all that activity, nebulae keep their softness. They are not sharp like a planet's edge or a moon's crater line. They fade into themselves. Their borders feather outward. Their light seems to seep rather than flash. Even when you understand the physics, the emotional effect remains the same. You are looking at something vast that behaves gently, something energetic that appears calm, something full of information that never feels eager to show off. Soon that softness will deepen, because some of the most haunting parts of nebulae are not the glowing regions at all, but the dark lanes and thick folds where dust hides what lies behind. And those quiet shadows, far from being empty, turn out to be some of the most important places in the entire story. Those quiet shadows are where nebulae become even more beautiful, because the dark parts are not simply gaps where nothing exists. They are often the opposite. They are places where a little more matter has gathered, where dust has become thick enough to interrupt the light behind it, where the galaxy seems to draw a slow breath and let one part of the scene turn inward. A dark nebula does not shine in the ordinary sense. It is visible because it stands in front of something brighter, cutting a shape out of the glow, the way a tree branch cuts into twilight. It is a kind of cosmic silhouette, and somehow it can feel even softer than the light it hides. That may seem a little backward at first. You might expect the most interesting part of a nebula to be the glowing gas, the luminous curtains, the rich pinks and blues. And those regions are lovely, of course. But the dark dust is where the mood changes. It gives the cloud depth. It makes the bright parts feel brighter. It creates edges, folds, and hidden rooms inside the larger shape. Without dust, many nebulae would lose some of their mystery. They would still be beautiful, but they would not have that same sense of quiet architecture, those shadowed valleys and soft barriers that make the whole scene feel layered and alive. Dust in space is a wonderfully modest thing to have such dramatic influence. These grains are tiny, often smaller than smoke particles, made from materials such as carbon compounds, silicates, ice in some colder places, and other heavier elements forged in earlier generations of stars. Nothing about an individual grain is especially grand. If you could hold one, which you absolutely cannot in any practical bedtime narration way, it would seem unimpressive. But gather countless grains across light years of space, and they begin to shape entire visible regions of the galaxy. They absorb light, scatter light, and dim the stars behind them. They turn open brightness into lanes and knots and ribbons. It is one of those recurring cosmic habits. Very small things, arranged patiently, begin to matter enormously. The dark band running through the Milky Way in the night sky is part of the same story. When you see that pale river of starlight broken by shadowy stretches, you are seeing clouds of dust between you and more distant stars. The galaxy is not patchy because the stars forgot to show up in certain areas. It is patchy because dust stands in the way, soft but effective, making some directions feel deeper and more secretive than others. So even before you start looking at famous nebula photographs, you have already met interstellar dust. It has been there the whole time, politely ruining your clear view and improving the atmosphere at the same time. Some dark nebulae are so distinctly shaped that people have given them names based on what they resemble. There is the Horsehead Nebula, probably one of the most famous examples, where a dense column of dust and gas pushes into a brighter background and produces the profile of a horse's head with almost absurd elegance. There are others that look like snakes, pipes, wolves, or ink stains drifting across starlight. The names are human, of course, a little playful, a little earnest. Space itself is under no obligation to resemble farm animals, but the shapes help us remember what we are seeing, not empty holes, but dense clouds holding their form against the light. And that density matters. A dark nebula is still extraordinarily thin by everyday standards, yet it is denser than the surrounding interstellar medium. That slight increase is enough to change everything visually. Dust grains absorb and scatter visible light so efficiently that a cloud can look black even though it contains material that may later become something radiant. The darkness is temporary in a larger sense. It is not the end of the story. Often it is the beginning of another one. Because inside some of these denser dust clouds, gravity begins its slow, patient work. This is one of the most soothing patterns in astronomy. The places that look hidden are often the places where something is quietly gathering. A dark nebula can shelter the conditions needed for future star formation. Dust helps cool gas by affecting how energy moves through the cloud, and cooler gas is more willing to collapse under gravity. The cloud does not suddenly crumple like a dropped blanket. It contracts slowly, unevenly, over immense spans of time. Denser pockets form inside larger clouds. Those pockets can become cores. Those cores may eventually become protostars. So a shadow in space can be less like an absence and more like a cradle with the lights turned down. Keep that strange calmness nearby, because it will matter soon. Dust also changes what telescopes can see. Visible light is easily blocked by dense dusty regions, which is why dark nebulae can look so opaque in ordinary images. But infrared light can pass through dust more effectively. This has allowed astronomers to peer into regions that once seemed sealed shut, revealing young stars, warm structures, and patterns of gas hidden inside. It is a beautiful reminder that darkness depends partly on how you look. A cloud that seems completely closed in visible light may become translucent in infrared. The secret was never absolute. It was only waiting for a gentler kind of sight. That is true in a very literal scientific way, and it also feels quietly philosophical, which astronomy keeps doing without asking permission. Some of the most iconic images from modern telescopes come from these dusty regions. Pillars, globules, ridges, and knots appear where intense starlight and stellar winds from nearby hot stars shape the cloud over time. Radiation can erode the outer layers of denser clumps, carving them into tall forms and leaving darker cores intact for a while longer. This is how you get those extraordinary structures that look like towers or fingers rising through glowing gas. They are not permanent monuments. They are temporary sculptures made by light, pressure, and density. The universe, apparently, is very good at erosion on scales that make mountain ranges seem adorably small. And still, even in these shaped regions, dust remains gentle in spirit. It does not explode into attention. It veils. It softens. It holds back. If glowing nebulae are the visible music, dust is the hush between notes. You need both to feel the full atmosphere. There is another reason dust is so important, and it reaches all the way into your own existence. Dust grains in space are part of the wider distribution of heavier elements in the galaxy, elements made in stars and spread outward over time. Carbon, oxygen, silicon, iron, and many others do not appear from nowhere. They are forged through stellar processes and then released by winds, eruptions, or stellar deaths, eventually joining the material of future clouds. That means interstellar dust is part of the long recycling system that enriches galaxies. Not glamorous, perhaps. Dust rarely gets the dramatic soundtrack, but it is essential. And because it is essential, it becomes beautiful in retrospect. A lane of darkness across a glowing nebula is not only a visual contrast. It is matter in transition. It is stored possibility. It is one of the ways the universe keeps resources on hand for later brilliance. The dim fold you pass today may, over enough time, contribute to stars, planets, comets, minerals, atmospheres, maybe even someone else somewhere looking up and wondering why the cosmos prefers such soft edges. You begin to notice that nebulae are full of this pattern. Nothing stands alone. Light reveals dust. Dust shapes light. Young stars illuminate the cloud that helped create them. Radiation sculpts the very material from which later stars may form. One process leans into another, and the whole thing unfolds so slowly that violence, where it exists, becomes visually transformed into calm. That may be one of the deepest comforts in studying the sky. Scale changes emotion. Events that would feel chaotic up close can look serene from a distance of light years and millennia. Soon, that hidden gathering inside dust clouds will lead you toward one of the gentlest and most astonishing facts in astronomy: that some nebulae are not only beautiful clouds but stellar nurseries, places where stars are formed with extraordinary patience, as if the galaxy has all the time it could ever need, which, to be fair, it does. That patience is the heart of it. Inside those darker, denser regions, where dust has gathered and light has been softened, gravity keeps working with the kind of quiet persistence the universe seems to prefer. It does not need drama. It does not need a countdown. It simply keeps tugging. Atom by atom, particle by particle, broad clouds begin to collect into denser pockets. These pockets do not collapse all at once. They cool, shift, compress, and slowly separate into regions that become more distinct from the space around them. Over immense stretches of time, some of them begin the long process of becoming stars. This is why so many nebulae feel tender even when the science inside them is powerful. A stellar nursery is not a factory in the ordinary sense. It is not efficient in the way people usually mean that word. It is patient, uneven, and full of pauses. A giant molecular cloud, often cold and rich in hydrogen molecules, may drift for ages before certain regions become dense enough to collapse. A nearby supernova shock wave may help compress part of the cloud. The pressure from hot young stars may squeeze another part. Turbulence may shuffle material into filaments and knots. And somewhere inside all that slow rearranging, gravity finds a place to deepen its hold. A giant molecular cloud is one of the main birthplaces of stars. These clouds are among the coldest large structures in the galaxy, often only a few degrees above absolute zero. That phrase sounds severe, but the feeling of it is actually rather peaceful here. These are not cold things in the sharp, icy sense of winter metal against skin. They are cold in a deep space sense, where heat is sparse, motion is subdued, and the cloud has settled into a state that allows gravity to gradually become more persuasive. Cold gas resists expansion more weakly than hot gas, so when a cloud cools enough, it becomes easier for parts of it to contract. That is one of the quiet secrets behind star birth. To begin shining, a star first needs a place calm enough to gather. As a denser region collapses, it forms what astronomers call a protostar. This is not yet a true star in the fullest sense, because nuclear fusion in its core has not started in the steady way that defines a main sequence star. But it is no longer just loose cloud matter either. It is a forming object, growing warmer and denser as gravity pulls material inward. The center heats up, gas falls toward it. Angular momentum, which likes to complicate everything with perfect politeness, causes some of the material to flatten into a spinning disk around the protostar. And suddenly, the scene becomes even more beautiful, because now you have a warm central object, a surrounding disk, and a hidden future beginning to take shape. That disk matters enormously. It is the kind of detail that starts small and then keeps echoing through the rest of cosmic history. Around young stars, those disks of gas and dust can become the raw material for planets, moons, asteroids, and comets. So inside a nebula, star formation and planet formation are often closely related parts of the same larger process. The cloud does not merely create a light in the dark. It may also create the surrounding architecture of a future system. It may be preparing, with stunning calm, for worlds. You do not see most of this directly with ordinary sight, because the earliest stages are often hidden inside dust. But telescopes that observe infrared and radio wavelengths can peer deeper into these nurseries, revealing warm cores, embedded young stars, and long filaments of gas where gravity is slowly sorting the cloud into new structures. What once looked like a single soft blur becomes, under more patient observation, a whole landscape of births at different stages. Some stars are just forming, some are already glowing strongly, some have begun to shape the cloud around them. The Orion Nebula is one of the most famous places where this story becomes visible. It is close enough by cosmic standards that astronomers have studied it in remarkable detail. To the unaided eye under a dark sky, Orion's sword contains a faint fuzzy patch. Through telescopes and long-exposure images, that patch opens into a vast glowing nursery of gas, dust, and young stars. Inside it, astronomers have found protoplanetary disks around newborn stars, little flattened systems that may one day become full planetary families. It is one of the loveliest facts in the night sky. Even in a region known for its soft glow and visible beauty, the real wonder runs deeper. The cloud is not just there to be admired. It is busy making futures. And the stars it forms do not all come out the same. Some are small, cool, and long-lived, red dwarfs that can shine for immense spans of time, longer than the current age of the universe in some cases. Others are larger, hotter, and far more luminous, shaping their surroundings with intense radiation and stellar winds. Massive stars are rare compared with smaller ones, but their influence is enormous. Their ultraviolet light ionizes surrounding hydrogen, causing parts of the nebula to glow. Their winds can carve cavities and compress nearby gas. They become, in a sense, both children of the cloud and architects of its next chapter. That feedback is one of the most beautiful ideas in nebula physics. A cloud gives rise to stars, and then the stars begin changing the cloud that made them. Radiation pushes, winds sweep, dust is eroded or reshaped. New dense pockets are compressed while others are dispersed. It is less like a single event and more like a conversation that changes tone over time. If you could float through such a region very slowly, the scene would be far more spacious and delicate than most images first suggest. The glowing gas would be thin beyond ordinary intuition. The newborn stars would sit inside cavities and folds, surrounded by material that had not yet joined them. Some areas would look softly illuminated, others dark and dense. Jets from certain young stars might stream outward along magnetic axes, producing narrow flows that crash into nearby gas and create bright knots known as Herbig-Haro objects. Even these, which sound a little energetic, unfold on scales and timescales that return everything to calm. The universe seems to enjoy making dynamic things appear serene from a respectful distance. And that distance changes your emotional sense of creation itself. On Earth, birth is immediate, loud, and intimate. In a nebula, birth is extended across thousands to millions of years. A star's beginning is not a single instant you could circle on a calendar. It is a long becoming. A region of cloud thickens, a core forms, a protostar heats, fusion eventually ignites in a stable way. Surrounding gas is blown away or used up. The star emerges more clearly. The nursery changes around it. There is something profoundly restful in that sequence. It gives creation room to breathe. It also helps explain why nebulae are often crowded with stars of different ages. A single giant cloud can form many stars in clusters or associations. Some begin earlier, some later. Some massive stars quickly alter the environment, influencing what happens nearby. So a nebula can contain both very young stars and regions where future stars are still hidden. Time overlaps there. The cloud is not working from a single schedule. Keep that in mind, because later you will meet nebulae formed not by beginnings but by endings, and it will matter that the universe recycles so gracefully. For now, remain here among the nurseries, where gravity gathers dust and gas into warm centers, where disks spin quietly around forming suns, where hidden stars begin by taking shape in the dark. This is one of the gentlest truths in astronomy. Some of the most radiant things in the universe begin inside cold, obscured clouds, protected for a while from open view, as if brightness itself prefers a slow introduction. That slow introduction makes the next part of the story feel even more beautiful because the universe does something unexpected with endings. It does not always treat them as clean exits. Very often, it turns them into clouds again. Matter that once belonged to a star can be returned to space, stretched outward into luminous shells, drifting filaments, expanding rings, and delicate veils. So some nebulae are not places where stars are beginning at all. They are places where stars have already finished one chapter of their lives and gently handed their material back to the dark. It is one of the most relaxing truths in astronomy, even though the first version of it sounds a little severe. Stars die. That part is real. But from far enough away and over long enough timescales, what you mostly notice is transformation. You notice that the universe does not waste much. It rearranges. It returns. It lets one kind of structure dissolve into another. The result can be astonishingly graceful. There are different ways stars end, and the kind of nebula that follows depends a lot on the star's mass. Smaller stars, including stars somewhat like the Sun, do not end in the huge explosive drama people often imagine from movies that are very committed to glowing debris and emotional music. Instead, late in life, such a star swells into a red giant. Its outer layers become looser and less securely held. Pulsations and stellar winds begin to carry material away into space. Over time, the star sheds those outer layers, and the hot exposed core left behind emits ultraviolet light that energizes the surrounding gas. That gas glows, creating what is known as a planetary nebula. The name is misleading, charmingly so. Planetary nebulae have nothing to do with planets. Early astronomers using small telescopes thought some of these roundish, glowing objects looked a bit like the disks of distant planets, and the name stuck in one of those classic scientific moments where a label politely refuses to update itself for centuries. But the objects themselves are lovely. They are often symmetrical, ringed, layered, or softly elongated, and they can look like floating lanterns in the dark. A planetary nebula is brief by cosmic standards. The glowing shell may remain visible for only tens of thousands of years before it disperses into the wider interstellar medium. That is not brief in any ordinary human sense, of course. It is plenty of time to misplace your keys many thousands of times, but for astronomy, it is a passing phase. A star spends far longer quietly fusing hydrogen in its core than it does wearing this final glowing veil. That fleeting quality makes planetary nebulae feel especially delicate. You are catching a short-lived moment when a star's outer layers are lit from within by what remains of the core. The Ring Nebula in Lyra is a famous example. Through telescopes, it appears as a softly glowing ring, a shell of gas expanding into space. The ring's shape is partly an effect of geometry and perspective. The nebula is not just a flat circle any more than a bubble is just a ring. It is a three-dimensional structure, and from our angle it looks as though we are peering through its luminous edges. The Cat's Eye Nebula is even more intricate, with nested shells, knots, and patterns that make it look almost ornamental, as if the dying star briefly became an artist with a strong preference for symmetry. And the symmetry is not always perfect, which somehow makes it better. Sometimes companion stars, magnetic fields, or uneven mass loss shape the outflow into lobes, jets, and more complicated forms. So even in an ending, the cloud keeps a personal trace of what happened. The geometry remembers. Then there are the deaths of much more massive stars which can produce supernova remnants. These are also nebulae, though their origin is far more violent. A massive star lives quickly, burns through its fuel, builds heavier elements in its core, and eventually reaches a point where the balance fails. The core collapses. The outer layers are blasted outward in a supernova explosion. It sounds intense because it is. But over time, the aftermath becomes one of the most hauntingly beautiful classes of nebulae in the sky. A supernova remnant is an expanding cloud of gas and dust moving outward into the surrounding medium. The debris can form shells, tangled filaments, arcs, and rippling fronts where shock waves heat the gas and cause it to glow. In the immediate event, the energy is enormous beyond easy comparison. But the nebula left behind, viewed across centuries or millennia, often looks calm. The violence has been stretched out by time into a kind of cosmic lace. The Crab Nebula is one of the best known. It is the remnant of a supernova seen from Earth in the year 1054, recorded by observers in Asia and elsewhere. Today it appears as a complex web of glowing filaments, still expanding, still shaped by the energy of the collapsed stellar remnant at its center, a neutron star spinning rapidly and sending power into the cloud. The Veil Nebula is another remarkable supernova remnant, spread across a large area of sky in delicate threads and arcs. In photographs, it looks almost impossibly light, as if someone had pulled glowing silk apart by hand and left it suspended in the dark. This is the strange calm of destruction. Matter can be hurled outward at incredible speed, and yet if you step back far enough in time and space, the result becomes serene. The harsh instant is real, but it does not define the entire visual life of the event. Eventually, what you see is expansion, cooling, mixing, and the slow return of elements to the galaxy. And those elements matter. Massive stars are crucial makers of heavier elements. Through nuclear fusion and through the final processes tied to explosive death, they help enrich the interstellar medium with oxygen, silicon, sulfur, calcium, iron, and more. The exact pathways are complex, but the broad truth is restful and profound. Some of the material needed for rocky planets, air, oceans, and living chemistry becomes widely available because stars live, change, and die. A nebula born from a stellar ending is not simply a memorial, it is also a contribution. That changes the feeling of the word destruction. It becomes less about erasure and more about release. You can picture one of these remnant nebulae spreading through space, mixing its enriched gas with nearby matter, seeding future clouds with ingredients they did not yet have. Later, another region may cool, collapse, and form new stars. Around some of those stars, disks may gather into planets. The cycle is not neat enough to fit on a greeting card, but it is real. Birth and death are not arranged in separate cosmic departments. They overlap, trade materials, and leave traces in one another. Remember that silent dust from earlier. Some of it was once inside stars. Some of the dust in future nurseries may come from endings like these. There is something deeply comforting in the fact that the universe builds magnificence out of recycling. It also helps explain why nebulae have such emotional range. Some seem like cradles, some seem like ruins. Some are both at once, depending on where you look and how much of the larger cycle you keep in mind. A glowing shell around a dying star can feel gentle rather than tragic because nothing about it suggests final silence. It suggests continuation through change. The star has altered. The cloud has appeared. The matter is moving on. Soon, that motion will become even more human in another way, because once you start seeing these clouds clearly, you realize how often people name them after familiar forms: horses, eagles, rings, butterflies, rosettes. The shapes are not the science itself, but they reveal something sweet about us. Faced with these immense drifting structures, we cannot help reaching for names that make them feel briefly knowable. That impulse to name things is one of the quieter, sweeter parts of astronomy. You look into space at an object so large it could swallow distances your mind would rather not calculate before bed, and your first instinct is to say it looks a little like a horse, or an eagle, or a butterfly, or a ring, or a flower. It is wonderfully human. Faced with something remote and immense, you reach for the familiar, almost as if your imagination is laying a small handrail across the dark. Nebulae seem to encourage that response more than almost anything else in the sky. Stars are too point-like for it. Planets are too self-contained. Galaxies can be elegant, but from a distance they often keep their own larger geometry. Nebulae are different. They fold, spread, feather, knot, and curl. They form edges that suggest profiles, cavities that resemble wings, arcs that look like petals, columns that seem carved on purpose. Of course, none of these shapes were designed for human recognition. A nebula is not trying to resemble a bird any more than a coastline is trying to resemble a face. But when light and shadow gather in the right way, the mind cannot resist making a story out of the outline. This is not a flaw in perception. It is part of how perception works. Your brain is deeply skilled at finding patterns, especially familiar ones, in incomplete or ambiguous information. That tendency has a name, pareidolia, and it turns up everywhere. People see shapes in clouds, faces in windows, animals in rock formations, and apparently entire zoological departments in interstellar gas. The same instinct that helps you identify meaningful forms quickly in everyday life also comes with you into astronomy. It is part of why the sky feels less alien than it should. Even at absurd distances, you keep finding hints of things you already know. The Horsehead Nebula is one of the most famous examples because the resemblance is unusually clear. A dense dark cloud stands in front of a bright glowing background, and from our viewing angle the silhouette really does suggest the profile of a horse's head and neck. The shape is striking enough that once you see it, it is hard to unsee. Yet the science beneath the image is very different from the name. The Horsehead is a small part of a larger star-forming region in Orion, shaped by dense dust and gas, radiation from nearby stars, and the slow sculpting effects of the surrounding environment. The horse is only the mask your brain places over a much more intricate physical story. And somehow that makes it better, not worse. Because the naming gives you an easy entrance, while the science gives you depth. First you recognize a shape, then you learn what actually produced it. A dark cloud stands against ionized gas. Ultraviolet radiation from nearby hot stars illuminates the background and erodes the cloud's outer layers. Density differences inside the cloud allow some structures to persist longer than others. The result is a visible silhouette that looks poetic from a distance and precise under study. Human imagination opens the door. Physics furnishes the room. The Eagle Nebula works in a similar way, though the part most people know best is a smaller region within it, the pillars of creation. The name is wonderfully dramatic, perhaps a little overdressed for the occasion, but the image itself earns some of that reputation. Towering columns of cold gas and dust rise inside a glowing region, shaped by radiation and stellar winds from nearby massive stars. The pillars look almost architectural, like stone monuments or cathedral ruins lit from behind. In reality, they are temporary structures, being slowly eroded over time. But temporary in a nebula still means patient enough to seem eternal to human eyes. That is another lovely thing about named shapes in space. They remind you that form can exist without permanence. The Butterfly Nebula is another case where the label feels immediately understandable. This planetary nebula has lobes of glowing material extending outward in a way that suggests wings. Its structure is likely shaped by mass loss from a dying star, possibly influenced by a companion star or by the geometry of the outflow. The result is symmetrical enough to feel almost intentional. But again, the universe is not decorating. It is simply following the laws of motion, pressure, radiation, and geometry. Beauty is what happens when those laws become visible. Then there is the Rosette Nebula, named because its broad circular arrangement of glowing gas and darker lanes can resemble a flower. The name is softer than the object's true scale deserves, which is part of the charm. Call something a rosette and it sounds like it might fit on stationery or an expensive pastry. In reality, it is a vast emission nebula with a cluster of young stars at its center, whose radiation helps shape the surrounding cloud. Once again, the name gives you a familiar image, and the science reveals the deeper structure. Hot stars, ionized hydrogen, cavities carved by stellar winds, and a larger cloud still carrying material for future changes. What makes these names especially interesting is that they depend on perspective. A nebula is a three-dimensional structure, often with layers, cavities, filaments, and shells extending through space. From Earth, you see it from one angle. That angle can produce a form your mind recognizes. From somewhere else in the galaxy, the same nebula might look entirely different. The horse might vanish. The ring might become an oval shell. The flower might lose its petals. The pillars might turn into a messy cluster of ridges with no obvious grandeur at all. So the named shape is not the whole truth. It is a meeting point between the object and your location. That does not make it less real. It makes it more intimate. You are always seeing the universe from somewhere, never from everywhere. Every nebula you admire carries not only its own physics but also the geometry of your viewpoint. You do not simply look at the object. You participate in the appearance of it by standing where you are. There is something calming in that thought. You are tiny, yes, but not irrelevant. The angle matters. Astronomers, of course, go far beyond the nicknames. They classify nebulae by physical type: emission, reflection, dark, planetary, supernova remnant, and more. They study spectra, densities, temperatures, chemical composition, motion, and magnetic structure. They measure how radiation shapes the gas and how stars influence their surroundings. Yet even within that serious work, the nicknames survive. The crab, the owl, the trifid, the flame, the lagoon. It is as if astronomy never quite lets go of the first moment of wonder, the first moment when someone looked into the eyepiece and thought, very softly, "That looks like something I know." And maybe that is exactly right. Because science does not have to erase wonder in order to become accurate. In the best cases, it refines wonder. It lets you keep the first emotional impression while giving it roots. The Eagle Nebula can still feel majestic after you learn about ionized gas and evaporating globules. The Ring Nebula can still feel like a floating jewel after you understand the expanding shell of a dying star. The Horsehead can remain a horsehead even after it becomes a lesson in backlighting, density, and erosion by radiation. The names are a bridge, and bridges are useful at night. They allow the mind to cross from image into understanding without losing the mood. That matters for a subject like nebulae, where so much of the emotional experience comes from softness, shape, and suggestion. You are not only learning facts, you are learning how human perception meets cosmic structure. You are discovering that part of the beauty lies not just in what the cloud is, but in how your mind receives it. And there is one more quiet lesson hidden in all this naming. Familiarity is one of the ways humans make peace with scale. The universe is staggeringly large, older than ordinary thought likes to manage, and full of distances so wide that language starts to feel thin. But give one drifting cloud a name like butterfly or rosette, and suddenly the abyss has a softer face. It is still vast. It is still indifferent to your schedule, your emails, your coffee going cold on the desk. But it becomes approachable for a moment. You can carry it in memory. Soon, that memory will stretch in another direction, because even the light showing you these familiar shapes has been traveling quietly for years, centuries, and sometimes far longer. A nebula is never seen exactly as it is in some perfect present moment. You always meet it a little late, which turns out to be one of the gentlest facts of all. That little delay is one of the most comforting truths in astronomy. When you look at a nebula, you are never seeing it in a perfect, immediate present. You are seeing light that left some time ago and has only just arrived. The cloud is there, or was there in that visible form when the light began its journey, and only now does the image enter your eyes, your camera, your telescope, your quiet room. Space does not deliver anything instantly. It sends everything by patient travel. Light moves very fast, faster than anything else we know how to describe in ordinary nature, and still the universe is so large that even light often seems unhurried. It takes about 1 second to travel from the Earth to the Moon. It takes a little over 8 minutes to come from the Sun. Those are already strange facts when you sit with them for a moment, but nebulae live much farther away. Their light may travel for hundreds or thousands of years before reaching you. Some of the most famous nebulae in the sky are close enough, by cosmic standards, to be measured in mere hundreds or low thousands of light years. That word mere is doing some aggressive emotional lifting, but astronomy uses it anyway. A light year is not a measure of time. It is a measure of distance, the amount light travels in 1 year. And light covers a truly unreasonable amount of ground in that time, nearly 9.5 trillion kilometers, or about 5.9 trillion miles. These numbers can become dull if they are dropped on you too bluntly, so it helps to keep the feeling instead of the arithmetic. A light year is what happens when speed meets vastness and still needs a year to finish the trip. So when you look at the Orion Nebula, you are seeing it as it was about 1,300 years ago. The light entering your eye tonight began traveling long before telescopes, long before electricity, long before most of the modern world had arranged itself into anything recognizable. If you see the Crab Nebula, you are seeing light that left roughly 6,500 years ago. The star that exploded to create the visible supernova in 1054 was seen from Earth then because the explosion itself happened that many light years away. In other words, the universe does not show you distant things live. It shows you preserved light. There is something deeply soothing about that. The sky is full of arrivals. Every point of glow above you is a small act of persistence. The light survived the journey. It crossed the dark without getting lost, which feels almost too poetic for physics, but physics is not at all embarrassed by beauty. It simply keeps doing what it does. Photons leave a hot star or a glowing gas cloud or a reflection off dust, and then they travel. They do not get tired. They do not speed up because you are curious. They do not slow down because the night is calm. They just continue. And because they continue, looking into space becomes a way of looking into time. That idea is often presented as something dramatic, but it is much gentler than it sounds. You do not need to imagine yourself plunging backward into history through some wild cosmic tunnel. You can simply picture this. Every distant object in the sky is sending information that takes time to reach you. The farther away the object is, the older the arriving image becomes. Near things are recent. Far things are ancient by the time they arrive. So a nebula is not only a place. It is also a message in transit, a visible memory still crossing space. This helps explain why astronomy can feel so different from ordinary seeing. On Earth, most of the things you look at appear almost instantly to your senses. The delay is too small to matter. You look at a tree, a window, a cup, a street lamp, and the light from those objects reaches you in tiny fractions of a second. The world feels immediate. In astronomy, that illusion of immediacy begins to soften. A nebula 1,000 light years away is, in visible terms, 1,000 years in the past. A galaxy millions of light years away becomes something older still. The farther you look, the more ancient the arriving light. And yet it never feels old in a dusty, lifeless way. It feels alive because it is arriving now. That is the beautiful paradox. The event is past at the source, but present in your experience. The light may have begun its trip before your language took its current shape, before your city existed, before countless generations lived and disappeared, but the moment you see it, it becomes part of your night. The universe keeps very old appointments with remarkable accuracy. Nebulae make this especially moving because they are so visually soft. A star can look like a point. A nebula looks like an atmosphere, a suspended place, a drifting region. To realize that this soft cloud is also old light still on its way gives the whole image a deeper calm. You are not just admiring shape and color. You are receiving history without urgency. It also means that change in the cosmos reaches you slowly. Nebulae do evolve. Gas expands, dust shifts, stars are born, radiation sculpts cloud edges, supernova remnants spread outward. But many of these changes happen over such long timescales that, from a human life, the object seems nearly still. The delay in light and the slowness of physical change work together to create a profound sense of steadiness. A nebula feels patient because, in every relevant way, it is. This delay also leads to a lovely scientific habit. Astronomers often study different parts of the universe as if they were looking through layers of time. Nearby star-forming regions show you relatively recent stages in cosmic structure. More distant galaxies show earlier eras in the universe's history. With nebulae inside our own galaxy, the time depth is not usually as extreme as it is for distant galaxies, but it is still enough to remind you that seeing is never entirely current. Every observation is slightly historical. Keep that image close, the sky as a collection of gentle delays. Even the colors you see have been waiting. A red glow from hydrogen in a nebula may have left when people on Earth were building with stone, sailing by stars, or living in cultures whose names most modern listeners never hear often enough. Blue light reflected from dust may have begun crossing space while whole kingdoms rose and vanished here below. And through all of that, the photons kept going, indifferent in the calmest possible way. No hurry, no commentary, just motion. There is another subtle comfort in this. It means the universe is not presenting itself all at once. It arrives in pieces, in measured travel times, in soft layers of age. You do not face the cosmos in one overwhelming instant. You meet it through delayed light, a little at a time, according to distance. The night sky becomes less like a single ceiling and more like a deep field of staggered arrivals. That may be one reason people find stargazing so emotionally regulating, even when they do not know the science. The light itself has traveled with extraordinary steadiness. It brings that steadiness with it. A nebula does not flash into view demanding your attention. It comes to you after a journey longer than any human project, any nation, any memory. By the time it reaches you, it has already practiced patience beyond measure. And that patience becomes even more astonishing when you remember what nebulae are physically like. They look full, rich, and almost velvety in photographs, but their material is spread so thinly that emptiness still dominates them. Their shapes are grand. Their substance is sparse. Their presence is strong. Their density is delicate. That contrast between appearance and physical thinness is one of the most quietly extraordinary things about them. That delicacy is one of the strangest and most beautiful facts about nebulae, because they rarely behave the way your eyes first assume they do. In photographs, a nebula can look dense enough to touch. It can seem like a curtain, a plume, a wall of vapor, a glowing blanket spread across the dark. The colors feel rich. The folds feel layered. The bright edges seem almost solid. Your brain, which is trying its best with the information available, quietly translates all of this into something familiar. It imagines mist, smoke, storm clouds, maybe ink in water. But the actual physical cloud is far more diffuse than any ordinary image suggests. A nebula is mostly emptiness. That is not a poetic exaggeration. It is one of the core realities of interstellar space. Even inside a comparatively dense nebula, the number of particles in a given volume is astonishingly low by earthly standards. In the air around you right now, there are vastly, absurdly more molecules packed into each cubic centimeter than there are in the gas of a typical nebula. The comparison is so uneven that the mind almost stops finding it useful. A cloud in Earth's atmosphere is dense enough to block your view because it contains an enormous number of tiny water droplets close together. A nebula can block light or glow across the sky because it stretches across distances so huge that even sparse matter becomes visible when enough of it lines up along your line of sight. That last part matters. A nebula often looks substantial because you are seeing through a great depth of cloud spread over light years. It is not dense in the way fog is dense. It is extended. The beauty comes partly from accumulation across distance. A few particles here, a few more there, and more beyond them, all arranged across a gulf so wide that the total effect becomes luminous or dark or softly textured. The universe gets away with this trick constantly. It takes very little substance, gives it extraordinary room, and somehow ends up with grandeur. This changes the emotional feeling of a nebula once you really absorb it. The cloud stops seeming heavy and starts seeming almost impossibly delicate. You realize that its glowing curtains are more like traces than walls, more like a hint stretched across the dark than a thing you could ever walk through and call thick. If a spaceship passed through many nebulae, it might not notice much visually at close range. There would be no cozy glowing hallway of red gas outside the windows in the dramatic way films sometimes prefer. The famous colors and structures are often the result of long exposures, processing, and a distant view that allows large-scale patterns to emerge. This is not disappointing, it is somehow better. Because it means nebulae are masters of subtlety. They achieve splendor with almost nothing. Their drama is made from restraint. Their visible presence depends on thin material, faint light, and distances so broad they let tiny effects accumulate into something majestic. If stars are the obvious performers of the cosmos, nebulae are the quiet designers working with light fabric and a nearly empty stage. There are, of course, denser parts inside nebulae. Some clumps and cores in molecular clouds become dense enough for gravity to pull them toward star formation. Dark globules and collapsing regions can be much richer in particles than the average interstellar medium around them. But even these denser pockets remain extraordinarily tenuous compared with anything familiar from daily life. The phrase dense in astronomy often means denser than the nearby space, not dense in the way your body, a wall, a mountain, or even ordinary air is dense. That difference is easy to forget and very soothing to remember. The universe works on a scale where almost nothing can still become enough. It also explains why light has such freedom inside nebulae. Photons can travel through many regions before interacting. Radiation from hot stars can carve patterns into surrounding gas because the cloud is not a solid obstacle. Shock waves from supernova remnants can sweep through tenuous material and create glowing shells and filaments. Stellar winds can hollow out cavities. Magnetic fields can help guide structure on large scales. Everything is working in a medium that is present but lightly present. The cloud offers resistance but gently. That is why nebulae often have those soft transitions, those feathered edges and transparent-looking layers. They are not painted with a hard brush. They are shaped in matter so thin that boundaries blur and light can leak, scatter, and fade. Even the darker regions owe their power to this balance. Dust may be sparse overall, but it is efficient enough at absorbing and scattering visible light that a modest increase in dust concentration can create a strong shadow. So the cloud remains mostly empty while still managing to produce both brilliance and obscurity. It is a very elegant arrangement. Astronomers often describe densities in terms of particles per cubic centimeter, and many nebulae have only a few hundred, a few thousand, or in some regions much fewer than that. Compare that with the air at sea level, which contains on the order of tens of quintillions of molecules per cubic centimeter, and the difference becomes almost ridiculous. The numbers are not close. They are not even in the same emotional neighborhood. Earthly matter is crowded. Nebular matter is spacious. And yet the nebula is the thing that stretches across the sky looking grand and theatrical. Scale wins again. This thinness also helps explain temperature in a more relaxed way. In a dense gas, particles collide often, sharing energy quickly. In a very diffuse gas, collisions are much rarer. That means temperature can become a more delicate, nuanced concept depending on how the gas is energized and how energy moves through it. Some parts of a nebula are cold enough to shelter molecules and future star formation. Other parts, especially those ionized by hot stars or heated by shocks, can be much hotter. But hot does not necessarily mean it would feel hot in the ordinary way, because there may be so few particles that the total heat transferred to something passing through would remain low. Astronomy is full of these moments where the familiar word stays the same while the physical experience changes entirely. So a nebula can be hot, glowing, and incredibly sparse all at once. That combination is part of its dreamlike quality. It behaves unlike ordinary weather, ordinary smoke, ordinary clouds. It is a cloud only in the broadest visual and structural sense. Once you step into the science, it becomes something far stranger and more graceful. A nebula is less like fog and more like the faint memory of matter spread over a cathedral-sized emptiness. Only the cathedral is light years wide, and the memory is glowing red, because hydrogen has been politely encouraged by ultraviolet radiation. And because these clouds are so thin, they are vulnerable to influence. Nearby stars can shape them, radiation can ionize them, supernova shock waves can compress them, gravity can draw some regions inward. The cloud responds not with sharp resistance but with yielding structure. It bends, glows, darkens, expands, collapses, and disperses according to its local conditions. It is a medium of transitions. That may be why nebulae feel emotionally different from planets and stars. A planet feels finished. A star feels defined. A nebula feels conditional. It is always becoming something, or fading from something, or reflecting something, or hiding something, or preparing something. It is made of almost nothing, yet it participates in almost everything important about galactic life. Soon, you will visit a few of the nebulae people return to again and again, the beloved ones that have become icons of the sky. And when you meet them, remember all of this thinness, because it changes the way you see their glow. The lagoon, the Orion, the rosette, the eagle, the veil, all of them are grand not because they are solid, but because they are delicate on a scale so vast that the galaxy itself seems to be breathing in color. That feeling of the galaxy breathing in color becomes easier to hold once you linger with a few of the nebulae people return to again and again. Not because the famous ones are the only beautiful ones. Space is much too generous for that. It is more that these particular clouds have become familiar doorways. They are the nebulae through which many people first learn what a cosmic cloud can be. And each one carries a different mood, a different balance of light, dust, shape, and history, as if the universe, without any need for branding at all, still managed to give them distinct personalities. The Orion Nebula is often the first great favorite, and it earns that place very quietly. It sits in one of the most recognizable constellations in the sky, and under dark conditions, it can even be noticed without a telescope as a faint blur in Orion's sword. That alone feels lovely. A stellar nursery, a real region of star birth, is visible to ordinary human eyes. You do not need to be operating a giant observatory on a mountaintop while wearing a very serious expression. You can simply look up. Through binoculars or a small telescope, the cloud begins to open. Through larger instruments and photographs, it becomes a glowing cavern of gas, dust, and newborn stars. The Orion Nebula is part of a larger star-forming complex, and at its center sits a group of hot young stars known as the trapezium. These stars help energize the surrounding hydrogen, causing the nebula to glow. Around them lie folds of gas, dark lanes of dust, and structures shaped by radiation and stellar winds. Astronomers have studied this region in extraordinary detail, finding young stars and disks that may one day become planetary systems. So Orion is not just pretty. It is active with beginnings. It is one of those rare objects that remains emotionally soft even after you know how much is happening inside it. Then there is the Lagoon Nebula, which has a different kind of atmosphere. It is broad, luminous, and rich with contrast, an emission nebula with dark lanes running through it and regions where young stars are helping shape the cloud. The name lagoon feels fitting because there is something aquatic in the way it spreads, something like a glowing inlet seen from impossible height. Of course, it is not water, and it would be very inconvenient if it were, but visually it has that same calm breadth. It reminds you that the sky often borrows moods from Earth without borrowing the actual materials. The Trifid Nebula offers another kind of beauty. Its name comes from the dark lanes that seem to divide the glowing cloud into three main parts. It is especially appealing because it combines multiple nebular behaviors in one place. There are emission regions glowing red, reflection regions with cooler blue tones, and dust lanes creating the split that gives the object its name. It is almost as if the nebula wanted to be a small demonstration of the larger story you have been gathering all night. Light emitted, light reflected, light blocked. A complete little lesson, but still elegant enough to avoid sounding like homework. The Rosette Nebula feels softer and more spacious. It forms a broad circular cloud around a central star cluster whose radiation helps carve out the inner region. In images, it can look like a flower made of gas and shadow, though a flower the size of a cosmic district is admittedly a little much. Still, the impression works. Dark lanes curl through the glowing shell. The center opens into a calmer cavity, and the surrounding gas suggests petals without ever becoming too literal about it. The rosette is a perfect example of why naming and science work so well together. The nickname gives you the feeling. The physics gives you the structure. The Eagle Nebula carries a more dramatic reputation because of the pillars of creation, those famous tall columns of gas and dust shaped by radiation from nearby massive stars. Even if someone does not know the name of the nebula, they may know that image. The pillars look almost sculpted, like giant weathered towers standing in a bright cosmic valley. Yet what makes them even more moving is the knowledge that they are temporary. Radiation is slowly wearing them down. Dense pockets inside them may be sheltering star formation. The structure is magnificent but not permanent. It is grandeur with an expiration date, which somehow makes it feel more tender. The Veil Nebula changes the mood again. This is the remnant of a supernova, not a nursery but a long aftermath, the glowing remains of a stellar explosion expanding through space. In photographs, the veil looks almost impossibly fine, like luminous threads, torn silk, or the edges of a ghostly curtain. It is one of the best examples of how destruction can become visually gentle over time. The original event was violent. The present cloud is graceful. When you look at the veil, you are seeing shock fronts and energized gas, but what your mind receives first is softness. The Crab Nebula feels more tangled and restless, though even there the chaos is strangely beautiful. It is the remnant of the supernova seen in 1054, and at its center lies a neutron star, a collapsed stellar core still powering parts of the cloud. Filaments spread outward in a web of glowing material, carrying the memory of the explosion in their motion. The crab is less delicate in appearance than the veil, but it has a kind of woven intensity, as if the cloud is still holding the shape of an event too large to be forgotten all at once. And then there are smaller jewels like the Ring Nebula and the Helix Nebula, planetary nebulae formed from stars more modest than the giants that create supernova remnants. These clouds often feel more intimate, more self-contained. They are endings with elegance, shells of gas lit by the hot remnant at the center. The ring floats like a luminous loop. The helix, closer to us, appears like a great cosmic eye in photographs, though thankfully a very calm one. They remind you that a star does not need to die spectacularly to leave something beautiful behind. What ties all these nebulae together is not just that they are famous. It is that each one expresses a different part of the larger cycle you have been following. Orion and the Lagoon speak of birth. The Rosette and Eagle show shaping and illumination. The Trifid teaches contrast. The Veil and Crab carry the beauty of aftermath. The Ring and Helix show quiet release. Together, they make nebulae feel less like isolated curiosities and more like moods in a single galactic language. And once you have met a few of them, the whole sky starts to feel fuller. A faint patch is no longer just a faint patch. It may be a nursery, a remnant, a reflection cloud, a dark lane, a place where light is being made visible by gas or softened by dust. The night becomes richer because you now know what kinds of softness can live inside it. Soon all of these separate clouds will begin to gather into one last wider feeling, where birth, dust, light, thinness, delay, and transformation all settle into a single calm image of the universe. And when they do, nebulae may start to seem less like objects scattered through space, and more like one of the cosmos's favorite ways of exhaling. By the time you have drifted this far, nebulae no longer feel like separate curiosities pinned across the galaxy. They begin to feel related, like different moods in one long cosmic breath. A dark cloud folding across starlight, a red nursery lit by young suns, a blue reflection cloud borrowing brightness from a nearby star, a fragile ring left behind by a fading giant, a veil of supernova debris spreading through the dark. All of them belong to the same wider rhythm. Matter gathers. Light reveals it, gravity shapes it. Stars are born inside it. Stars alter it. Stars return to it. And through all of that, the universe keeps choosing softness as one of its most beautiful visual languages. That may be the most relaxing fact of all. For all the enormous forces involved, nebulae usually appear gentle. Gravity, radiation, pressure, shock waves, magnetic fields, stellar winds, even death on a stellar scale, all of it becomes translated into folds, colors, shadows, arcs, and glow. The cosmos takes events far beyond human scale and lets them age into something calm enough to admire before sleep. It is not pretending those forces are small. It is simply letting time smooth their edges. And time in astronomy is very good at that. You can feel it in the way nebulae refuse to become hurried, even when they are active. A stellar nursery may be forming suns at this very moment, but the process stretches across spans so vast that the cloud still looks serene. A supernova remnant may still be expanding, but over centuries and millennia, the expansion becomes lace and filament. A planetary nebula may be drifting outward from a dying star, but what reaches you is a floating shell of light, not a scene of panic. Nebulae keep proving the same point again and again. Motion does not always look frantic. Change does not always look harsh. Some of the deepest transformations in the universe happen with an appearance of extraordinary calm. That changes the way you think about emptiness too. Space often gets described as empty, and compared with Earth it certainly is. But nebulae remind you that emptiness is not the same as lifelessness or absence. Between the stars there is dust waiting, hydrogen glowing, oxygen shining faintly, darkness gathering into denser knots, old elements drifting outward, future stars sleeping inside cold clouds. Emptiness in the galaxy is often a place where preparation is quietly underway. A nebula is one of the clearest signs that the space between things is not just between. It is part of the story. And perhaps that is why these clouds feel so emotionally generous. They live in the in-between. They are neither fully formed worlds nor simple points of light. They are places of transition. They carry beginnings, middles, and endings all at once. In one nebula you may find a young star burning hot, a disk forming around another, dark dust still hiding future stars, and nearby gas already being blown outward by radiation. In another, You may find the remains of a dead star turning back into a cloud that will one day mix with new material. Nebulae are not fixed monuments. They are passages. They are the visible form of becoming. That idea has a quiet comfort to it. The universe is not built only from finished things. Some of its most beautiful structures are temporary, changing, partial, unresolved. A pillar may erode, a shell may disperse. A dark cloud may collapse into stars. A glowing region may fade when the local energy source changes. And yet none of this feels wasteful. Nothing important is lost from the larger pattern. The material moves on. The light moves on. The story keeps breathing. Remember the thinness from earlier, how these clouds seem rich and full while being spread across enormous emptiness. Remember the old light, taking the long way to reach you. Remember the dust that hides and reveals, the names people gave to shapes they recognized, the nurseries where stars begin in the dark, the remnants where endings become luminous. All those details now settle together into one wider feeling. Nebulae are not rare interruptions in an otherwise plain universe. They are one of the clearest ways the universe shows you how it works when it is being both truthful and beautiful at the same time. And beauty here is not decoration. It is structure made visible. A red glow means hydrogen answering starlight. A blue haze means dust scattering light. A dark lane means denser grains blocking what lies behind. A shell means matter moving outward. A filament means gas responding to pressure and motion. A pillar means radiation sculpting denser cloud. The facts do not spoil the image. They deepen it. The more you understand, the softer the wonder becomes. It stops being surprise and becomes companionship. The sky no longer feels like something merely above you. It feels like something you have begun to know. Not fully, of course. The universe keeps its dignity by remaining larger than any summary, but a nebula offers a kind of friendship across distance. It lets you see one process at a time. It glows just enough. It hides just enough. It gives you color, depth, and mystery, but also clues. It is generous with hints. That balance is probably why people return to these clouds so often. You can look at them for beauty and stay for understanding, or come for the science and leave with a strange affection for drifting hydrogen and dust. By now, the galaxy may feel a little less cold than it did at the start of the night. Not warmer in temperature, obviously. Space remains committed to being wildly unhelpful in that department, but warmer in mood, perhaps, more inhabited, more textured, more patient. Nebulae do that. They make the universe feel less like a machine and more like a slow ecology of light and matter, where even silence has color and even darkness is carrying ingredients forward. And in the end, maybe that is what lingers most. The idea that some of the most magnificent things in existence are not the sharpest or the loudest, but the softest. Clouds that glow without rushing. Dust that hides futures. Light that arrives late and still feels right on time. Shapes so delicate they are mostly emptiness, and yet so vast they can hold the birth and death of stars inside them. It is a very gentle kind of grandeur. The kind that does not overwhelm you. The kind that simply keeps unfolding the longer you remain with it. So the next time you picture a nebula, you may no longer imagine only a bright cloud in a telescope image. You may picture a patient region of space where atoms, time, and gravity are making something beautiful without any need to hurry. You may picture the galaxy breathing out one colored cloud after another, leaving them suspended in the dark like thoughts it never needed to say out loud. And maybe, in that image, there is something worth carrying back with you into ordinary life. A reminder that softness can still be vast, that slowness can still be full of meaning, that the quietest things sometimes hold the deepest stories. Let that idea rest beside you for a moment. Let the bright clouds drift farther away now. Let the red glow soften, the blue reflection dim, the dark dust settle back into shadow. Let the named shapes loosen and become just clouds again, no longer horse or eagle or flower, just patient folds of matter floating in deep space. Let the old light continue on its way. Let the nurseries keep their hidden stars. Let the remnants keep widening so slowly you would never notice them move. Let the whole galaxy grow still in your mind, not empty, never empty, only spacious and calm. You do not need to hold every fact. You do not need to remember every nebula by name. It is enough to keep the feeling of them, vast and delicate, bright and thin, ancient and arriving, a universe that can turn gas, dust, time, and gravity into something so soft that it feels almost kind. And as the night grows quieter, you can leave those clouds where they belong, hanging far away in the dark, glowing gently without asking anything more from you. The universe will keep breathing in color. The last of the light grows softer now. The great clouds drift farther apart in your thoughts, and the sky becomes simpler again, wider, quieter, easier to rest inside. The red glow fades to a hush. The blue reflections become faint as memory. The dark lanes remain, but only as soft shadows, gentle and still. Above you, or somewhere beyond imagining, the nebulae remain exactly as they are, moving through their long, patient changes with no need to announce themselves. Stars will continue forming in hidden folds. Old shells of light will keep expanding. Dust will keep gathering, scattering, sheltering. And none of it needs your effort tonight. You can let it all continue without you for a while. There is comfort in that. The universe is busy, but never in a way that asks you to keep up. Its grandest things unfold slowly. Its brightest clouds are made from delicate matter. Even its most powerful changes become calm when seen across enough distance. So let your mind become spacious in the same way. Let the thoughts that still feel close begin to spread out and thin, the way a nebula stretches across the dark. Let them lose their sharp edges. Let them become lighter, quieter, less urgent. There is nothing to solve here, only distance, only softness, only the faint glow of old light arriving exactly when it can. And if one last image stays with you, let it be a simple one. A silent cloud in deep space, suspended in darkness, touched by starlight, carrying both memory and possibility, glowing softly as if the universe itself has chosen, very gently, to leave a lamp on in the night.